Hi, I'm David Kempsell. I'm the Managing Director of First Thought Equine and designer of Wow and Flair. I want to tell you a little bit about the Flair system, how it goes in the panels and how it works. Okay, so I'm going to give you a bit of insight into how the airbags sit inside the panels, and also why the airbags are shaped and sized the way they are, okay? So first of all, this is our sort of standard panel, as it were, the one we sell the most of. And you can see there's our airbag here, and it is contained within a Cordura bag or a nylon bag that basically stops it from stretching, stops it from expanding. Okay, so you'll see that this is what effectively makes the gusset of the saddle. So if I put the gusset round here, you can see it's shaped to the gusset. Okay, but in front, if I turn this over, you see the way the airbag sits. So you've got your back airbag, takes up about 2/3 of the length of the panel, and the front airbag takes up about half the length of the panel. Okay, so why the difference? Well, effectively the back bags are for the rider. The rider sits on the back. It doesn't really, a rider doesn't sit in the middle of a saddle. There's about 1/3 of the saddle sitting out the front. So also it's just the natural way that it tapers into the waist. So this is where the rider's leg is going to come off here. So we get a back bag that's effectively 3/4 of the length, and the front bag half the length, and the overlap in the middle means that we get a smooth transitions of pressures from back to front. Okay, so why this Cordura bag? Why not just have a bag that's not folded like this? Well, the whole point is that if this bag was not contained and not rolled up like so, what would happen is that all the air, as I can maybe show you, will contain itself here. If you look at this top corner, it's totally dead. So I've got air in here, quite a lot of air, but this is dead. Well, that's no good because we actually need lift at this point. So by having a rollover, what we do, when we put pressure on, you can see this corner actually wants to lift and expand. It wants to explode out, but it can't because the Cordura bag and also the panel is containing it. So what you get is a lift in this corner that you wouldn't get if it was like this. As you can see, there's no lift and it's dead. So it would actually go in against the withers, because this is, in this case, this is the front bag. And we do the same with the back bag. And this piece of material here, this foam, is actually there to stop your bag doing this and just rubbing itself out against one another. So it curls around and can move. So you less wear and tear. Also, while we're on the subject of wear and tear, if I do this, it's very slippery. And the reason for that is there's a silicone oil inside that bag that basically stops the airbag from wearing itself out. Now the important thing, Flair has now been around since 1998. It's not been beaten on pressure testing or on gait analysis. So in other words, taking the same saddle and putting Flair in it, you get much better pressures and you get a bigger moving horse. The important thing about all of this is, and there have been a few rip-offs of Flair around, note there's no nasty lumps, bumps or anything within this panel. All of the pipes and the transitions into the bags are very small, very subtle. This is covered by a piece of foam, which we'll come to in a minute, but basically there is nothing to stick into the horse. And this is the whole key to it. Especially the most important part is around here. And you'll see these airbags transition from being curled to being flat at this point. This is because the waist of any panel is going to be the narrowest or flattest at that point. So a panel will go from, say, 1.5 inches thick in the front down to about 3/4 of an inch in the middle as it transitions down where the rider's leg is, and then it will come back up to maybe 2.5 inches at the back. So the panel goes from thick to thin to thicker. So the whole point of this is that we want this to be as flat as possible. Now, I'm going to tell you something about what we call crisp packet theory. Okay, if we had a crisp packet here instead of an airbag, tie a knot in it so we keep the air in. Right, a crisp packet. Why do we put air, or why do we put gas in a crisp packet? It's not just so that the crisps don't go off, it's so we can't crush them. So we've got something solid. Air is actually hard. So we'll come to how we make Flair soft in a minute. But basically what you've got is a high pressure point, if you like, in the middle of this bag. Now I know you're going to say, well, the air is the same pressure, but it doesn't react the same, because if you look at the corner is very soft and very squishy. And if you were to squeeze your crisp packet, you couldn't squeeze it in the middle, but if you go to the corners, you can push the corners in. So the pressure the airbag exerts is relative to the surface area. So where the surface area of this airbag is greatest, that's where you'll get the highest pressure point. So basically, we need something to disperse this pressure. If I push down, as I said, what I can't get is contact in the middle, but I can easily get contact in the corners. So what we do is, where we have the highest pressure point, and it is, because effectively when you pressure test it, you would see that the airbag doesn't actually lay flat. The airbag wants to create almost like a ridge of pressure and a higher point of pressure in the center. So we're going to wrap this bag around this foam shock absorber, and then we're going to press down. And what we're effectively doing is forcing the air around the foam to the outside. The air wants to get where the foam is, and the foam wants to get where the air is. So what you have is this continual fight going on, where it actually creates a very flat, smooth bearing surface, and that is the whole point. Foam is a brilliant shock absorber, but it's very, very difficult to adjust. Air is really easy to adjust, add it, take it away very easily, but it's hard. So what you have is the air being a if you like, stopping you bottoming out onto the horse's back, and you've still got the shock absorbency of the foam, and you're using the shock absorbency of the foam really efficiently because of the fact it's in the highest area of pressure on the airbag. So the relationship of the length of the back bag and the front bag will vary dependent on the length of the panel. So a 19-inch panel will be slightly spread apart, whereas a 16-inch panel will slightly be compressed. But if you like, this area where they overlap will either get narrower as we push it more forward, so that we'll get a slimmer airbag and therefore less lift, or if we pull it back, we'll have a wider airbag, which will give us more lift. Okay, so these airbags, once when they start life, they're open. Okay, you can see in there the tube that we've just glued in. We're going to trim that away before we seal this bag. Now we're going to have a seal along here, and remember, a seal would normally be the weakest point on an airbag, but the way we seal it, it actually becomes very, very strong. But also, the fact that the seal is here, but the rollover effectively means that where the strain is applied is down the bag, where the bag is solid, and not at this point. In other words, we don't get a tearing force like so as the airbag expands, because where it's actually trying to expand is at this point here. So we relieve the pressure on the seam anyway. It's not until it gets down here, which is the corner of the bag, where it actually appears flat and we see the seam. But at this point is the least pressure. Where we see the highest pressure in this airbag would be around about here. Okay, so this gives us the ability to seal this bag at different lines to get different sizes and therefore different rollovers depending on where we seal the bag.